Hey folks, welcome back. Thanks for stopping by and watching my video. I know in the first class we talked about FTK Imager. So we started off with what is FTK Imager, and we talked about how to install FTK Imager, followed by different menu options within FTK Imager. And then I demonstrated how to open a physical drive and a logical drive and differences between the two drives. And at the end, I showed you how to image a drive. Now let me clear that. I know at the end of that video, I did mention that starting, my second video, I am going to load that image file that we created in the first video and show you different options and how it looks like. But then I thought about it and I decided maybe before we go to that video, I wanted to talk to you guys about file hash. So to start off, the agenda for today's class is what is a file hash? Why do we need it? Types of file hashes, how to get a file hash, hash collision, and when will a hash change? So to give you a real world analogy of what a file hash is, think about fingerprints. What is a fingerprint? A fingerprint is a unique pattern of ridges and valleys. They are really small, found on the fingertips of humans and also primates. Some primates, I mean. These patterns are unique to each single person and also to each finger of the same person. Until I researched this, I did not know that. I did not know that each finger had a unique pattern. And this makes it a reliable method for identification. And actually, fingerprints are formed before birth and they remain unchanged throughout your entire life. So when I mentioned that each finger has a unique pattern, what that means is, we hear about, say we hear about a burglary or a homicide. So they say, hey, we collected fingerprints, we collected partial prints. What that means is they collected maybe one or two prints of one or two fingers, and that's what they would use for comparison. Well, how we compare, that's beyond the scope of this topic. So in a similar way, a file hash is known as a digital fingerprint, and it is unique for each file. So what it does is a file hash is nothing but a unique fixed size string of characters that's generated from a file's contents using a cryptographic hash function. What it does is, since it gives a fixed string of characters, it then acts as a unique identifier for a file, allowing for verification of the integrity and the authenticity. So how it does is, we have a hash function. The hash function ingests the contents of a file, no matter the size, and processes it through a mathematical algorithm and generates a fixed length string, which is nothing but the hash value. So when I just mentioned, I said no matter the contents, right? So it could be a 1 terabyte file. And if you use, say, a SHA-1, it would give us a 128-bit hash or 32 hex characters, which would uniquely identify that 1 terabyte file. Uh, you will understand more as I explain and go through some of the examples. And one way to think about it is, sometimes say you download a file which is about uh, multiples of gigs, and when you download it, at the end, sometimes the program which downloads, they typically do checks to verify if the complete file has been downloaded and not corrupted. They use either CRC checks or a hash check like what I'm talking about right now. So different kinds of hashes. So we have, let me clear this. Now let me leave this. We have MD5, SHA-1, SHA-256. So starting with MD5. So this, when you run this specific algorithm against a file's contents, it provides a 128-bit hash or 32 hex characters. So what that does is it provides these 32 characters which can uniquely identify a file. What that means, two files cannot have the same exact values. I know once I explain these three algorithms, I'm going to talk about collisions. The next one is SHA-1. SHA-1 goes one level above. It's a different algorithm. What it does is, just like a hash, it does the same thing. It ingests the contents of a file and it generates a hexadecimal string or a string of characters, except unlike MD5, which had 32 hex characters, in this case, SHA-1 has uh, 64 hex characters. So now let's go one step above. So SHA-256, in this case, it's 256 bits or 64 hexadecimal characters. So what that means now, I said they can uniquely identify each file. However, there is a concept called collision. Collision means if two files having different contents have the same exact value, that's called a collision. So collisions have been identified in MD5 and SHA-1, but this has been replicated only in the lab, not in the wild. So as so back in the day, we used to use MD5 and SHA-1, but now because we have collisions, I believe Microsoft and few other companies, they recommend us to use SHA-256. Now, also another thing is, remember, like when until like 2010, say you had an account on a specific website and you forgot a password, and then you would click on forgot password, then it tries to authenticate you based on a few questions what you had mentioned earlier, or you answer a few questions and then they would give the password. So back at that time, some of these websites would store your passwords in plain text character. Like if you had a password as Apple, they would store that in the database as Apple. So when you forgot your password, they would give you back that same password, Apple. But then because databases started getting hacked, now what they do is whenever you have a password, they hash it and they store the hash value in the database. So next time you enter your password, it hashes it and it verifies if it matches what's in the database. That's why if you forget your password, they don't know what the password is. They only have the hash value. And mind you, I think I forgot to mention, you cannot reverse a hash to the actual file's contents. So same way, when they store a hash value in the database, they cannot re-engineer it to find what your actual password is. That's why now when you forget your password, they only give you an option to reset your password. They do not give you your actual password, what you had earlier. So now, how do we hash? So what I'm going to do is go to my favorite website, forensictools.com. I go to forensic tools, get away, and I go to this quick hash GUI. Click on download, and so this is quick hash. I have already downloaded it, and it is my favorite hashing tool. So I open quick hash. This is the GUI, what it looks like. Okay, so here you can hash whatever you want. Say I want to hash like I mentioned, a password, right? Let's say Apple, and I want SHA-256. Look, this is the hash value. Now let me change one character. See, I'm going to copy this and paste it here, and let me say apples. Boom, I just changed one character, and do you notice the hash changed? And so this is the quick hash GUI. So typically we use it for file. So here we have different algorithms that you can use. By default, when you open quick hash, it uses SHA-1. But like I mentioned earlier, since we have identified collisions in, damn it, I can't pronounce collision, I guess. Since we cannot identify, since we may have collisions in MD5 and SHA-1, now the preferred method is SHA-256. I've never used SHA-3. So now in this case, let's go to where the file is. Okay. So I have a folder called test. I have a file called test file. So this is the file. This is a randomly generated text within a file. Now what I'm going to do is I'm going to run through different scenarios. So here I'm going to just do it again. Test file, open, and here it generates the hash value. So then I'm going to copy this hash and paste it right here. Okay, so next I'm going to do one small change. I'm going to make one small change to the text file. What I'm going to do is this text file, there was already a space here. I'm going to add another space and I'll save it and select file. Okay. Look at that. I just added one space and the entire hash of the file changed. Now, let's change the file name and see how it behaves. So I am going to close this file and I'm going to change the name to test files. So let's go back, select file, test files, copy the hash. See, the hash did not change. What it means is, irrespective of the file name or the parameters or the metadata of a file changes, irrespective of that changing, as long as the contents remain the same, the hash is going to be the same. So let's try another thing. Let's change the extension of the file. So it is txt. So let's change it to PDF. Change it. Now I go to quick hash, PDF. Let's do it again. And look at that. It is still the same. Now, let's go to do uppercase to lowercase. Let's, before that, I'm going to change the extension back to txt. Yes. And let me open it here. Okay. So look at the first character, R. I'm going to change it to lowercase. So I'm going to make sure, you see these two spaces are still there. We do have it. And instead of R, just going to change lowercase, save it, and go back to quick hash, select test file.txt, click on this hash. See, the hash value changed. So even though one pixel or one bit of file's contents change, the hash is not going to match. That way, we can verify the integrity of a file. Now, going back to the file, let's change to caps, back to caps, save it, go back to the same file, select file, open, come back. Look, it is the same as it was earlier. Another thing what you could also do is, now say you have instead of comparing every single character, you can use the nifty tool. You can click on expected hash and see expected hash matches the computed file hash. Another thing what it can also do is it can compare all the files in a folder. So in my case, I had an issue with SQLite. That's why it's not working, but typically it should work. So when you click on files, you select a folder, all the files within that folder are listed and they're hashed. And then you can, at the end of the day, you can copy it and you can paste it to an Excel file. Let me see how I can fix this, and maybe the next class I'll show you how to compare, how to get all the hashes within a specific folder. Also, another thing what you can do is if you have in a folder, if you have multiple files, like say thousands of files, and some of them are duplicates, you can actually click on this, go to this files, and hash all the files within that folder and identify if they are repeated. What that means is they are duplicate files, and you can go ahead and delete them, and you can free up some space. That is all I have for today. Thank you for your time. Thanks for watching the video. And like I said, the next video I'm going to talk about I'm going to go back to FTK Imager and load the image file that was created in the first class. Thank you.